Okay, 4, 6, completing the square. So if you cannot find a factor or quadratic function, does that mean it does not have zeros? Consider the quadratic equation x squared plus 10x plus 12. And let's look at factoring this, right? So then we go 12 and 10. What multiplies to 12 and adds to 10? So 12 is 1 and 12, 2 and 6, 3 and 4. And no combination, we can get 10. So we know we can't factor this. But can we still get zeros? Remember, zeros are the points on the x-axis. So if you take a graphing calculator, or if you went to desmos.com and you put the equation in and hit graph, you will see that in fact it does have zeros. It has 0 between -1 and -2. So we're going to quickly sketch that. Somewhere between -1 and -2. And it has a 0 again between, so 1, 2, 3, 4, 5, 6, 7, 8, and 9. And if we want to go second and we want to go calculate the minimum, we're going to go to the left. And the right. The minimum is at -5, -13. So if we go to -5, -13, and put our point, then we can get this sketch of this graph. Oops, and I put my 5 in the wrong spot. That's why it doesn't look even. So there we go. Okay, so that's the graph. So it does have zeros. So it says use technology in sketch. Does it have zeros? Yes. How come we can't factor it? Because it's not rational. So the zeros are not rational, which means they do not form a ratio or a fraction or a whole number. So they're irrational values, which is why we can't factor it. So then how are we going to find those values? So that's the question. So we're going to use this method called completing the square. The quadratic function you graphed has zeros but cannot be factored, so you must consider another method for calculating its zeros. You can use your understanding of the relationship among coefficients of perfect square trinomials to construct a procedure to solve any quadratic equation. Previously factored trinomials in the form of a squared plus 2ab plus b squared as a perfect square a squared a plus b squared. This knowledge can help you develop a procedure to solve any quadratic equation. The expression x squared plus 10x can represent geometrically as shown. Write the area of each rectangle. So the area of this rectangle is x by x is x squared, and this one is 10 by x or 10x. Okay. This figure can now be modified into the shape of a square by splitting the second rectangle in half and rearranging the pieces. So they split this one here in half and rearrange the pieces to make these two rectangles here. By splitting the second rectangle in half, complete the side length tables for the split rectangle and write the area of each piece. So now if we split the 10 in half, we have 5 and 5. So this would still be x squared, and now we have 5x and 5x. Notice how 5x plus 5x is still 10x, like we had up there. So we didn't change the value, we just showed it differently. Do the two figures represent the same expression? So yes, okay, because the top one is x squared plus 10x, and the bottom was x squared plus 5x plus 5x, which is equivalent to x squared plus 10x. So complete the figure to form a square. Label the area of the piece you added. So we go back, and we're going to fill this in, which is why we call it completing the square. We're going to fill this in to complete and make the full square. And it wants to know what is the area of this piece. So this piece would be 5 by 5 or 25. Add the term representing the additional area to the original expression. So we had x squared plus 10x, and now we're going to add 25. That's the new expression. So if we take this paper, the new expression, x squared plus 10x plus 25. Okay. Factor the new expression. So we make our x, what multiplies to 25 and adds to 10? 5 and 5. So we have x plus 5 times x plus 5, which can be written as x plus 5 squared. This process you just worked through is a method known as completing the square. Notice how we completed the square by putting that full square. It's a process for writing quadratic expressions in vertex form, which allows you to solve for the zeros. Draw a model to complete the square for each expression, then factor the results. So this first one we'd have x by x for the x squared. And if we took the 8x and we split it, then this would be 4, and this would be 4. So we have the x squared, and we have 4x and 4x, which makes the 8x. And now we're going to fill in this little square to complete the square. How big is this square? So 4 by 4 is 16. So this complete square would be x squared plus 8x plus 16. And if we draw our x and factor this, what it multiplies to 16 adds to 8, 4 and 4, x plus 4 times x plus 4, or x plus 4 squared. So now we're going to do the same thing here. Draw out the x by x, or x squared. We're going to split this one to do the two sides. If we split 5 in half, we're going to put it as 5 over 2. Don't write it as a decimal. Leave it as 5 over 2. So this is 5 over 2x and 5 over 2x. And then this area here would be 5 over 2 times 5 over 2, or 25 over 4. So we have x squared plus 5, so is it 5x, because we have these, both of these, 5x plus 25 over 4. And if we factor that, what multiplies to 25 over 4 and adds to 5, it'd be 5 over 2 times 5 over 2. 5 halves plus 5 halves makes a whole 5. So we get x plus 5 over 2 times x plus 5 over 2, or x plus 5 over 2 squared. So what you should be noticing in every one of these problems is the final factored form. Okay, the final factor form in every problem is half of whatever this number is. So 10 is 5, and then that term squared. Half of 8 is 4, and then the squared. Half of 5 is 5 over 2, and then the squared. So now we're going to summarize what that means, and then you can practice this. So analyze your work in question 4. Explain how to complete the square on expression in the form x squared plus bx, where b is an integer. So writing it generically, what did we do to complete the square? We took the b and divided it by 2, and then we squared it. Okay, right? So we took if we think about the square, and we had x and x, how did we figure out the sides of these boxes? If the whole thing was bx, then these would be b over 2x. Okay, and then how did we find this little square? It would be b over 2 times b over 2, which is equivalent to b over 2 squared. So that's the generic formula. And then it says, describe how the coefficients of the middle term b is related to the constant term c. So again, that's what we just talked about. How do we find the middle term? It's going to be, you take half of b and square it to find c. Okay. And if we want to write our final term expression, it's going to be x squared plus bx plus b over 2 squared equals x plus b over 2 squared. So that's the generic form you follow. So you got to figure out this term and then factor it to that. That is completing the square. Okay, so let's look at number 6 following this method. And then once we do number 6, or A, you're going to do B, C, and D. So how do we find A? We do 1/2 of the B value, which is -8, which would be -4, squared equals 16. So we put 16 on this line. And it says, then write the expression as a binomial squared. So we're going to write our x because it is negative 8, it's going to be minus 4 squared. Okay, so whatever this sign is the sign you're going to use here. So do the next one, we're going to do half of 5, which is 5 halves squared, which would be 25 over 4. We just saw this one. 25 over 4. And then to do the factored form would be x plus 5 over 2, because it's whatever b over 2 is, squared. And then the next one asks us to find the number in here. So how did we work backwards? Remember, this number, 100, is b over 2 squared. So if we want to solve for b, if we take the square root, we get 10 equals b over 2, and then multiply by 2, b equals 20. So this would have started off with a 20x on this line. 20 divided by 2 is 10. 10 squared is 100. And then the factors here are, again, always minus, because it's half negative, or so negative 20 divided by 2 is negative 10 squared. And then do the same thing here. If we do 144 equals b over 2 squared, we take the square root. 12 equals b over 2, multiplied by 2, b equals 24. So 24x goes on the line, and then for the factors, it's plus because of the plus. Half of 24 is 12 squared. So completing the square, finding that value that makes the perfect square, and then when you factor perfect squares, because it's a perfect square, remember, perfect square, the two sides will be the same length. Right? And when you distribute them out, you will get the factor here. Right?